Okay, I think we can get started, and we will start with Raya from the University of Bologna.
I hope you hear me well. Yes, yeah, excellent. I have to say that as a disclaimer, so when I get the email from Daniele and from Michela to invite me to join this conference, initially I thought it was a spam, because I have a reason why. Because for most people maybe don't know what I work on, but in the past 10 to 15 years, my main expertise is I work on climate change. So I work on, particularly I got the ESC grant from the European Commission. So this is the 5th year of my research, and the project is called Pop Clima. So I work on the impact of climate change on population dynamics. So looking at how climate affects fertility, mortality, and migration, particularly as a demographer. So typically when we think about how population would evolve and look like in the future in terms of population projections, population trends and patterns, typically demographers don't build in the potential impact that climate change may have on fertility, mortality, and migration, which are the 3 key components of population change. So my idea is sort of, maybe if we start seeing some evidence already on these 3 components, and we may need to build that in when we think of how future climate would change and how future population will change in the future. So that's the whole idea. So I kind of try to make my talk relevant for the topic of this conference, which is on inequalities in longevity. So I thought, why not bringing in the potential impact that climate change can have on health and mortality on the table. And maybe it's relevant for us to think about, if we think about longevity, pension, and other things. So this thing, particularly the fact that climate is not affecting different locations and different subgroup of population in the same way. So bringing that thing on the table maybe can be relevant or helpful when we think about longevity and inequalities. But I want to start with this question. So I think today in Venice, probably now it's around 27, 28 degrees or 29. But what is your ideal temperature? So I just want to be precise. So daytime temperature that you feel comfort when you are outside. So not thinking about now we are in the acclimatized air conditioning room. So if you, and I'm glad that we have audience from different places in Europe or in the world. If you feel like 16 to 18 degrees is your ideal comfort temperature, can you raise your hand? 16, 18, no, I don't have anyone from Russia, maybe. Oh. In Rome. 19 to 21, that's probably the majority, I guess. 20 to 24, oh, that slightly surprised me. I'm actually originally come from Thailand. 25 to 27 degrees, maybe some of you as well. I just want to say, why do I ask you this? It's probably the majority of you say 21 to 23, right? This concept of optimal temperature or comfort temperature, or what the epidemiologists call minimum mortality temperature, is actually quite relevant, because anything below or beyond this minimum mortality temperature would mean the risk of mortality increase. So the MMT is when we observe the lowest mortality rate in a given population. And as you can see here from this number, it varies by cities. You may think it's actually probably not biological, but it's more like what we are used to, like what we are acclimatized. I think I have some colleagues from Stockholm, maybe some people also from the UK. So the minimum mortality temperature there is around 16, 17 to 18 degrees. And then it increased if you think about Rome, for instance, or Athens is 25 degrees. So this would be the type of curve that we have. No, this is a typical kind of mortality and temperature mortality response. The curve is more or less similar in terms of this U shape. So as I said, anything that goes beyond this MMT when it's colder, then mortality risk increase. It gets much steeper in the heat side because heat has more rapid effect on health and well-being. Cold takes longer time to develop if you think about respiratory diseases, influenza, and that kind of thing. So just to show you that, say, imagine at 21 degrees in Stockholm and London, we already start seeing a mortality increase, but not yet in Athens, for instance, because their MMT is different. Yeah. So why is it relevant to us? We just come out of one of the strongest heat wave on record. I think all of you remember, most of you live in Europe, so it hits actually also Western, Northern Europe, Southern European countries. Already someone already estimated that this heat wave is correspond to about 1,300 deaths. And if you think this is only the heat wave in June, probably more still to come in July and August. So it can be relevant when we think about this heat-related mortality. And the weather attribution, so these are the group of climate scientists that typically when they see extreme climatic events, can be floods, can be heat wave, drought, and many other things. What they do is to try to understand whether these events are linked to human-made climate change or not. So they also said that without anthropogenic climate change, so without the CO2 emissions that we put in the atmosphere, this heat wave that we observe wouldn't have happened. And as we know that climate change is getting worse, right? So this can be relevant when we think about life expectancy or longevity in the future. I just want to emphasize that the trends, so this is the observed trends comparing from pre-industrial level. So since the Industrial Revolution, 1860, until the current time, as we know, the global average temperature has been rising, but Europe is double the global average. Currently, we hit around 1.2, 1.3 degree above in pre-industrial level. Europe is about 2.3, 4, depend a bit on the measurement, but it's fast growing. Unfortunately, sad news, we actually getting higher and higher. So it depends on different projections. But if the emissions of the current time goes on as it is, we would probably reach around 2.7 degree by the end of the century. We only about 1.3 now, and we have already observed all the effects. So you may imagine 2.7 degrees in some places, and some people would be difficult to cope with. But one thing that this may surprise you or maybe not, that up until now, actually coal causes more deaths than heat worldwide. Actually, even in hot regions, if you think about sub-Saharan Africa, coal attributed death is actually 12% of the death. It's much higher than the heat related death in most of the places. So the question, looking forward into the future, I use AI, by the way, to make this picture. I thought I want to make the contrast between coal and heat-related death. The question that we could ask, so with climate change, right? I was showing you that coal-related death is much more common. It kills more than heat. So you may also say that, well, maybe that's a good thing because we would have less cold days, meaning decline in coal-related death. Of course, we would have also more hot days, maybe increase in the hot heat-related death. But these two things maybe just offset one another. For demographers, I don't want to sound impartial, but we need annual deaths, right, to calculate the future population. So if it just offset one another, maybe we doesn't have to care about the impact of climate change on mortality. So that's one question to look at. It is an empirical question, right? Would these two trends offset one another or not? The second thing that I want to bring onto the table is what is called harvesting effect on mortality displacement. You may remember in COVID time that the older population are much more sensitive, like over 80s, 90s in particular, are much more sensitive to COVID than other age groups. But some people also argue that these are the frail people that probably in the next 2 months, they're probably likely to die anyway. So the frail people, so what COVID did, or maybe what the heat wave did, maybe just shift the mortality forward. So by the end of the year, it's just the same number of people who die, it's just shift the timing. So if this harvesting effect happen again, we have to care about the impact of climate change on mortality? So that's the question. So what we did is we took the data from Italy, so we know in the period 2011-2022, so I know the mortality rate by different provinces of Italy. So I look at the relationship, look at the temperature distribution. So I see that actually in this time period already in Italy, what I see is heat-related deaths. So the 95th percentile correspond to around 26 to 30 degrees. So I see much more higher death in the heat side, but also on the cold side as well, the 5th percentile. I have problem clicking. Okay. So how do I look at this harvesting effect? What we do is to rank the winter mortality and summer mortality. So see in this 10 years time period, which winter that I observed the highest mortality, and then ranking them, right? Because what I would expect if harvesting effect happen in the summer that follow the high winter mortality, so I may see lower mortality in that summer because the frail people already die in that high winter mortality. So I have to say that we did pick some of the harvesting effects. So this is around in the summer, when the temperature is around 25 degrees, roughly, depends on the geographical location in Italy, so 98 to 95%, it's quite hot. In high winter mortality, I don't see the peak in mortality in this heat. And so we say that probably we observe this harvesting effect. On the other way around, in low winter mortality, the mortality increase. But when it's very hot, and I think this is important because going forward into the future, this is probably the likely temperature that we're going to get, right? When it goes to 95th percentile, the temperature distribution corresponds to around 26 to 30 degrees, depending on the location. Doesn't matter anymore. Do I have high winter or low winter mortality? Because when it gets that hot, even the frail people may die in the previous winter. We would have more people dying, and I think this is quite alarming. I don't have much time, but we did some of the projection as well for the EU country. What I want to say that in different, this is 25 European countries, different countries may benefit slightly from less cold and then increase in heat, lower cold winter-related mortality, but by the year 2050, look at the blue one, which is the likely scenario. This is the business as usual. That's a trend of this time continue. By 2050, we don't see mortality increase, but later because temperature keep on increasing, so this heat-related mortality may really increase, and that's a type of trends that we likely to see actually in the future. But now I want to get into the differential vulnerability part, because we just get into the inequalities topic, and I think this risk framework, which I take from the Intergovernmental Panel for Climate Change, so IPCC framework, can be useful when we think about climate-related risk. For risk to happen, think about mortality. So I would stick with this heat example. Hazard need to happen. So heat wave needs to happen, right? But is heat wave happen where no one lives? So we don't need to care. So the location, exposure, if people live in the urban area, for instance, or maybe the southern geographical location in the area with less green space would be more exposed. Also depend on your occupation. People who do outdoor work would be more exposed to this heat hazard. Thinking that people may be equally exposed, but maybe the degree of sensitivity or susceptibility or vulnerability may not be the same, as we see the older population have less capacity to thermoregulate extreme temperature, for instance, so they're much more sensitive. So the physiological susceptibility is there. Women also biologically have less ability to thermoregulate extreme temperatures. So even though the eco-exposure, maybe sensitivity is different. And of course, the things like adaptive capacity differs, right? We can think about like access to air conditioning, income, housing quality, social network, social isolation, and so on, which can play a difference. So all these layer of inequalities, if you like, can affect your risk of health risk or mortality risk. I want to bring in this work that we're doing for the Lancet Commission, because the interest of this Lancet report, what they want to know is how migrants do. So I thought the example of migrants can be useful to understand this layer of inequalities, how migrants fare when they migrate already to Europe. And if they get exposed to some kind of climate change, some kind of climate impacts, what is their health impact? What is their mortality or health patterns? And we can try to unpack this layer of different inequalities by looking at differential exposure, differential vulnerability, and differential health outcomes. And that's what I'm going to try to do in 4 minutes. Okay, so first the question are migrants more exposed to heat, right? I just stick to heat as an example. So what we did is to look at the distribution. Where do migrants live in different subnational regions in Europe? Not street level, it's a province level in Italy, for instance. And then look also at the distribution of where the native born refers to people who were Italian, who were born in Italy would be called native born, right? So compare the exposure to this heat related. If you see the red bars, both in the map and in the red bar here, it means that migrants, typically what we pick, it's kind of tend to be more exposed. They tend to live more in the urban area, for instance. So it seems to be that in terms of exposure, they tend to live in the hotter area than the native. So that's one thing. But one could also ask the next question, but are they more vulnerable? Maybe more exposed, but migrants are young population, likely to be healthy population. Maybe they're fine, right? So we look at another question, like taking some of the characteristics that kind of determine the health-related risk when people get exposed to heat, things like the type of housing. Do they live in institutionalized housing, like home care, prisons, for instance, crowded type of housing, that look at the type of employment, educational attainment. Education has been popped out as something important, and that's what we find as well. And then see if these combination, like do they tend to also work in agriculture, manual work, and that kind of thing. It seems to be that the redder the colors, also migrants tend to be more vulnerable in all of these indicators too. But you can also ask the next question. They seems to be more exposed to heat, seems to be more vulnerable, but what is the ultimate thing? Do they get their health? Do they have poorer health? Some of you may know the healthy migrant effect. I guess maybe yes, maybe no, but I could explain a little bit. So typically migrants, because migration is selection. Not everyone migrate. Actually, only 3.5% of the world population live where they were not born. So it's super selective, if you think, and tend to be slightly positively selected. Because if you are in poor health, you're probably not going to move and change places, right? So in fact, this healthy migrant effect is found all across the different regions. Actually, migrants tend to have actually higher life expectancy and lower mortality risk compared to the native born. Of course, you can argue, but the health advantage that that carries with them, this selection may decline because they may face discrimination, they may live in poorer housing, and so on. So in fact, this is what we show here. No, I have the native born here, European migrant in the middle, and non-European migrant on the right. I have different health indicators. Self-rated health is the blue one. Limiting long-term illness is the red one. And then I have comorbidity, the green one. And as you can see here, it's actually the non-European migrant tend to be healthier. So they do have this healthy migrant effect. I have 3 more slides and I'm almost finished. But I would ask further, I want to dig further. No? So I use the panel data. So it's data that follow the same people over time in Germany. Because now what I want to see, I see the differential exposure, I see differential vulnerability, I see migrants are healthier. But when they get exposed to heat wave, so the 5 hottest days of the year, do they have worse health? And this is what we find. Actually, just give you an example of different indicators. I have mental health, morbidity, I have general health, but this is what we see. The German-born European migrants get exposed to heat. They don't have the decline in health as much as the migrant is the one on the right. And that's what we see in all health indicators. So, so that's what I want to say. So even though they are healthier, but when get exposed to some kind of climate, they have poorer health in all of the indicators that we look at. The final thing, we can try to unpack actually also what are these sources of inequalities that we see when migrants get exposed to health. In the first, this model here, as you see, so we control for age, we control for their employment status, control for sex. What we see is, yes, this TX5D plus non-European migrants have poorer health, but we can dig further. What about if I see if controlling for if they have access to air conditioning, the number of rooms of the house that they live, because migrants tend to live in crowded space. Do they have garden? Do they do manual work or not? Once we account for all of these characteristics, the difference between the non-European migrant and German-born disappear. So this is my final slide that I want to say that if you have to do some kind of policy intervention, I'm not talking about only migrant population, because anyone who maybe do manual work, live in poor housing, and that kind of thing also would be to make them more vulnerable to, in this case, in this example, is heat-related mortality. So one could do the intervention in that place, because it's not biological, it's more structural. I'm stopping here. Thank you.
Thank you, Raya.